So we have done with integer data type. Now moving forward to our next data type, that is float data type. It is a real number with floating point representation. It is specified by a decimal point. For example, a equals to 5.5 is an example of floating point value. We can also check the type of a by using the inbuilt function type. So we need to pass a within parentheses, and now it is showing the type is float. Now we can also represent a floating point number in scientific way. What I mean by scientific representation is, for example, we have a floating point number like this. Now if I print a, so now it is showing like this, 2.1 e to the power minus 19. This is nothing but the scientific representation. We can also represent this number, or we can also store this number this way in Python. So what we need to do is a equals to 2.1 e to the power minus 19. So it is also valid. Now we can only use decimal number system to represent a floating point value, otherwise it will raise an error. Like if I try to represent a floating point value in binary form, then it will raise an error like equals to 0b 1100.0b 1100. It will raise an error like this. So our next data type is complex. It is basically used in mathematical calculation, where the concept of complex number is involved. It has two parts, one is real and another one is imaginary. And this imaginary part is declared with j, like a equals to 5 plus 6j. And here also this j can be written in uppercase or in lowercase. It will not raise an error. So here 5 is real part and 6 is imaginary part. Now we can also declare a complex number like this, p equals to 7j. Here I have not declared any real part, so it means the real part is 0, or it is similar to 0 plus 7j. Okay, now if I print the type of a, so it will be showing complex type. Similarly for b also, it is complex. And we can also use arithmetic operations on this data like addition, subtraction, multiplication, etc. For example, c equals to a plus b. Now if I print the value of c, so it is 5 plus 13j. One of the notable point about this complex data type is this real part and this imaginary part can also hold a float value. Python will not going to raise an error. Like if we declare a variable like 5.5 plus 6.6j, then Python will not going to raise an error. It is also a valid declaration. And another point is c equals to, if I declare a complex variable like 0b1100, which is the binary representation of 12, and plus 4.5j, then also it is a valid declaration, because in real part we can store the value in any form like binary, octal, hexadecimal or decimal. Python will not going to raise an error. But in case of imaginary part, we can only store the value in decimal format only, otherwise it will raise an error. Like d equals to 0b1100 plus 0b1100j. Now it is going to raise an error because imaginary part can hold only decimal form. Okay. Now coming to the last numeric data type, that is Boolean. In this we have only two inbuilt values, that are true and false. It is basically used in logical operations, and also it is used to create conditions and control how the program behaves when certain things happens. For example, if you try to know whether 5 is less than 7 or not by writing a equals to 5 less than 7. Now Python will going to give the value in Boolean form. If it is true, then it will give true, otherwise it will give false. And the value will get stored in a. Now if I print a, so it is showing true. And this line will print the type of a, that is Boolean or bool. So this is all about numeric data type. Now we will learn different inbuilt functions that can be operated on numeric data types. So our first function is apps. Apps basically takes a numeric data or a negative numeric data like minus 45, and it will print the absolute value or the positive value of that number. So in our case it is minus 45, so it will print plus 45 or 45. We can also pass negative floating point value like 4.5, so it will print positive 4.5. Within apps function we can also pass a complex number like 3 plus 4j. So in this case it will going to print the magnitude of that complex number. So our question is how to calculate the magnitude of a complex number. For example, we have a complex number that is a equals to 3 plus 4j. Now we need to calculate the square of these numbers, that is 3, the square of 3 that is 9, and the square of 4 that is 16. And then we need to add them. And again we need to find the square root of 25 or the addition, that is 5. So 5 is the magnitude of a. Now if I print the answer, now it is showing 5.0. But note that it is showing a float value, that is 5.0. Because if we print the type, that is type of apps of 3 plus 4j, so it is showing float value. So if we pass a complex number within apps, it is going to print the magnitude of that complex number, but it will return the answer in float data type.